In this example, it's not obvious that the equation that we're solving is a radical equation, meaning that it has a root on it. However, we need to recall this definition of what happens when we have a fraction exponent. If we have a fraction exponent, let's say x raised to the a over b, then by definition, as long as b is not 0, b is the root we're taking, and then a is the understood exponent on the x underneath. So x to the a divided by b is actually a root. So in this case, this would be rewritten as the fourth root of x to the first power. And then we would still have the 3 on the right side. To solve radical equations, we first want to notice if our root is even or odd. In this case, it's an even root because of the fourth index. If you have an even root, make sure that whatever's on the right side is positive, which in this case it is. That means that when you solve this, whatever solution you get is a legitimate solution. Next, we want to raise both sides to the power that undoes the root. So in this case, the root's 4, so we would want to raise both sides to the fourth power. Notice that I didn't choose to keep the 1 as an exponent on the x. I don't need it because anything to the first power is just itself. Now, because I'm raising a fourth root to the fourth power, the root and the fourth power cancel, leaves me with just x. And then 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. We know that this is a good answer because originally we had the even root isolated on the left and we had a positive value on the right, which means that you will always have a good answer